We're going to graph y equals negative 2x, or negative 1/2 x, plus 4. So I'm going to start with my table. And this time I'm going to think about, I wanted to talk to you about this negative. Do you see how close it is? So a lot of textbooks, it's really easy to miss that negative. So what I like to do is when I rewrite them, I like to, instead of writing my negative right there, what I like to do is rewrite it right with the up top, and sometimes I even go at an angle up here, because it just helps me see it and visually see it. So if it's down there, you just have to really be careful that you're not missing it. All right, so I'm going to start with my 0 in the middle, and that's where I'm going to start with my calculation. So I'm going to go over here and some sideline math. So negative y 1/2 times x plus 4. So that 0, this time I'm saying 0 is x, so I'm going to substitute that in. 0 times the negative 1/2 is 0, plus 4 is 4. So y is 4 when x is 0. Now, if I put a 1 in my problem here, I'm going to have being substituting a 1 in here, and that's going to be 1/2, negative 1/2 times 1, and then I'm going to get a fraction. So I'm thinking I kind of want to use an easier number to kind of help me do my calculation right now. So I'm going to choose 2, because what happens in our equation when we substitute that in, negative 1/2 times 2 plus 4. So I can put that over 1. So that's going to cancel out my 2's. So 2 goes into 2 once, 2 goes into 2 once. So negative 1 times 1 is a negative 1. So negative 1 plus 4 then is y equals positive 3. So what happens is, instead of calculating out a fraction like I would if I did a 1, I calculate out a positive, or like a whole number or integer. So my next number, because I kind of see that denominator of 2, so I'm thinking, oh, my next number I'm going to choose is the next even number. So y equals negative 1/2 times 4 plus 4. So I'll make a fraction out of the 4. 2 goes into 2 once, 2 goes into 4 twice, so I'll simplify the 2's out. So 2 times negative 1 is negative 2, plus 4 is a positive 2. So I see a pattern here. So this next one will be a minus 1. So that'll be 1 and a 0, and then the next one will be negative 1. But then over here on the x side, it's going to go up by 2. So 2, 4, 6, 8, and 10. And I suppose you're wondering what's happening up here. So we'll go the other way, going down to, so negative 2, negative 4. We could go to negative 6 if we wanted to squeeze it in there. And then as we're going up here, we can see that pattern going up 4, 5, 6, and 7. So those are our coordinate pairs that we can graph. So I'll start by going over 2 and up 3. That's my first. I like that first point, 2, 3. So over 2, up 3, over 4, up 2. Oh, that was over 3, up 2. So I need to over count again. 2, 4, up 2. Over 6, up 1. Over 8, up 0. Oh, it's right there on that x-axis. Over 10, down 1. Oh, and I see my pattern here. It's left 2, up 1. 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 left 2, up 1, left 2, and up 1. And I'm at the edge of that graph. So notice my table didn't go that far, but I'm able to use my pattern from my linear pattern and be able to draw my straight. So I'm grabbing my ruler now, and I'm lining up the crosshairs really carefully so that I get a nice straight line. Kind of go back and forth to make sure that it's straight through those crosshairs. Ooh, I missed it just a little bit. So I would probably, if I was on my paper, I would go back and redraw it. And then I went past my graph because I'm a little bit low right here. So it's really kind of difficult with my board, but with a graph paper, you would go back. Down here, it's really nice because I see how I caught that crosshairs right there. So now if we go to our special cases, these are a little bit more trickier. So I want you to get 2 more graphs that are kind of close together. So for this one, we're still going to make a table. And that table, it looks differently. This equation looks very different than last 2 we did. So I kind of think about, well, if x is 0, I have to read my equation. Y is 3. So that equation, y is 3, so that means y is 3 when x is 0. So x is 0, so it says y is 3. So I'll put it in there. So my next one I'll pick is x is 1. So if x is 1, and I'll read my equation, y is 3. Oh, so I'll just put a 3 in there. So it's very different. These are the special cases that come up now that we're in algebra. So the next number I'm going to pick, if x is 2, what is y? Y is 3. If x is -1, I'll read my equation, y is 3. So that means there is a 3 in the y for every x. So whatever I plot my points, I'm going to have a y that's 3. So I'm going to go over 1. I'm going to plot the 1, 3. So this coordinate pair is 1, 3. So over 1, up 3. Put a point. Over 2, up 3. Oh, if I plot 0, 3, over 0, up 3, over -1, up 3. So that means all these points will be all 3s. So I'm going to draw my arrow, getting it all the way across. So I'm going to pick 2 points at the far ends and draw my line, extend out, and put arrows on at the end. So that is the graph of y equals 3. And it's a special case. It's a horizontal line. So a horizontal line, that is our y equals 3. So that's very different than our y equals 3x. When we had 3x, we were able to calculate and multiply 3 times the number x. But for this one, it's just y equals 3. And that's why it's a special case, because it's a horizontal line. So now our last one that we're going to do is we're going to do x equals -2. So we're going to think about our table, and it's sort of like the one we just did, but this time our x's are all going to be -2 because that's what it says, x equals -2. Now notice that the x isn't with the 2, it's a special case. So that means that x is always -2. So y can be 1, 2, 3, and 4. So if x is -2, y is 1. If x is -2, y is 2. And I see that this is a vertical line. So we'll line up our ruler, making sure it gets nice and straight up and down on those. All right, that is needing to be corrected. Okay, and I have my ruler upside down, so I was having a hard time getting it in the right place. Aha, much better. So a lot of times we need to be able to get our line correct in that right spot. I'm going to get a little bit of, I got this little piece right here, so I'm just going to erase that. And we have a straight line with arrows on the outside of the box. And that is how you graph linear equations.